A random sample of 13 men's resting pulse rate shows a mean of 70.7 beats per minute and a standard deviation of 17.5. We are asked to find a 95% confidence interval. So you can do this in StatCrunch, and I think that's the approach I'll take, where I'm going to open StatCrunch. And since we're talking about means, I'm going to go to where it says Stat, choose T-Stats, one sample. The data is summarized for us because they tell us the mean and standard deviation. I'm going to enter that information into here. So the mean was 70.7, and the standard deviation was 17.5, and the sample size is 13. And we're looking for a 95% confidence interval, and it's currently set up for us. And that information is displayed here, the lower and upper limits. We're going to round this to the nearest tenth and list it in ascending order from smallest to largest. So that is 60.1 and then 81.3. Okay, so starting with 60.1, okay, we have four options, and it has to be either B or C to say we're 95% confident, and we're really trying to find something out about the population mean, not the sample mean. So I'm going to go with B. We are 95% confident that the population mean for resting pulse rates is between, I already forgot, is 60.1, and then it was 81.3, 81.3. Okay. The difference between A and B is now we're looking for a 90% confidence interval. So in StatCrunch, a quick way to do this is instead of like going through, stat and opening all that stuff up again, if you click on where it says options and choose edit, the information we entered is already there, and I'll just simply change the confidence level from 0.95 to 0.90 for 90%. Okay, this is the new interval, and I believe we're going to round and enter our answers in the same way. So let's see. The lower one's going to be 62.0. So we're 90% confident that the population mean, so I want to choose this one here. So that was 62.0. And the upper limit was 79.4. And okay, the interval is smaller than the one in part A, but that makes sense because we're less confident. So I'll check my answer. Oh, and part C goes on to ask, well, which interval is wider and why? So the wider interval is the one where you have more confidence. You have to include more stuff to be more confident. So the 95% interval is wider because it has a greater level of confidence. And so we use a bigger value of t, which creates a wider interval. So it's going to be A that is true. We didn't actually compute this t star value, which can come from this table, but that's what StatCrunch uses to actually get the values for this interval. And I'll check my answer, and that's it for this problem.